Hello everyone, this is FIXST Maintenance College. I'm Anthony. From now on, we will have iPhone 8 repair course. Today, we will begin Lesson 1, iPhone 8 Power On Principle. Before we start our class, we need to understand the power on process first. Number 1, battery provide power to main power of PCB. Number 2, main power start to work when press power on button. And main power provide 28 circuits of low voltage power to mobile phone. Number 3, main power provides 16 circuits of low voltage power and 1 circuit of reset signal to CPU. Number 4, CPU start to work and check itself. Number 5, CPU verify load components by I2C. Number 6, CPU verify the logic EEPROM by I2C. Number 7, CPU verify the NAND. 8, the NAND start to work. And number 9, CPU extract data from NAND and make the phone on. As we know, if we want the phone on, it needs power. And the power is from battery. The battery is connected to J3200 and pin 1 output positive power PP BATT VCC. And the U3300 transform positive power of battery to PP VDD MAIN and output to PMU. Then U3100B positive transform PP VDD main to PP VDD boost and output to PMU. And the PMU works need PP-VDD main and PP-VDD boost. Let's check battery connector of PCB. Battery is connected to PCB. The positive power is from PCB. Let's check it out. The positive power of battery is output from here to this charging component. This component is called U3300. It transforms PP BATT VCC to PP VDD main. And then output to PMU. That is powered. After U2700 receive power, PMU will stand by. And the power on bottom is integrated in bottom cable, and the cable connected J4300. And then let's check pin 13. Pin 13 is the power on bottom working signal and PMU working signal. When mobile phone standby, J4300 pin 13 has 1.8 voltage power, and this moment shows this function is not activated. The Y3000 is clock crystal of 32.768 kHz. It provides clock signal to PMU. When the phone connected to the power, Y3000 start to work. When you press the power on button, it means make pin 13 to GND. And the voltage of pin 13 is changed from 1.8 voltage to 0 voltage. When PMU cannot detect the 1.8 voltage of pin 13, that means PMU need to work. And this status will stay 3 to 5 seconds. Then PMU working. After receive power, PMU start to work. This is power bottom connector. When we connect the power bottom connector, if we want PMU to work, It needs 32.768 kHz clock crystal. After PMU work, it provides 28 low voltage power to PCB, 16 of which are sent to the CPU to provide necessary power for the CPU. When CPU receives power, it will stand by. And after the CPU receives power, the Y1000 24 MHz clock crystal will provide the clock signal to CPU. After that, the PMU sends reset signal to CPU, and CPU returns to original state. And next, CPU works after it receives 16 lines low voltage power of PMU, reset signal and 24 MHz clock signal of Y1000. And then CPU starts to work and check itself. In the meantime, CPU verifies load components by I2C and verifies the logic E point by I2C. Also, it will verify the NAND. And finally, CPU extracts data from NAND and make the power on. When PMU receives power, press the power button. PMU start working. If the 24 MHz clock crystal OK, PMU will output many lines of power to CPU. And CPU receive power, it will get the clock crystal. Then CPU start working. After CPU working, it will take the power on data from NAND. Now let's check 24 MHz clock crystal of CPU. This is the 24 MHz clock crystal of CPU. Okay, when we know the process, let's check no power on repair idea. The steps of no power on repair idea. First of all, you need to take out the PCB and connect to the power cable and power supply. Then check the current. If the current shows 0 mA, it means PMU is not working. Just check PMU power PP VDD main and PP VDD boost OK or not. If not, check and replace relevant components. And then check the starting signal of PCB power on bottom OK or not. If not, replace the cable and make jumper. Then check the Y3000 clock crystal of PMU OK or not. If not, replace the new one. When repairing the power error, we need to check the changes of current. Firstly, connect PCB to power supply. Then turn on the phone. Now it's on. Check the starting current. It is helpful for our repair. Number 2, if the current shows 0 to 50 mA, it means PMU is working, CPU not working. Check 1.8 voltage of CPU reset signal OK or not. If not, it means CPU is broken. Stop repair. And then, check Y1000 clock crystal OK or not. If not, replace the new one. Next, check 16 lines power of CPU OK or not. If not, check them short or not, or replace PMU. Number 3, if the current shows 50 to 80 mA, it means PMU is working, CPU is working, the NAND not working. First of all, connect the phone to PC and check the phone is in DFU mode or not by iTunes. If yes, root it. If not, take out the NAND, connect to PC and check again. And after take out the NAND, connect the phone to PC again. If iTunes detects the iPhone, replace NAND and root. If not, check USB control lines. After that, we will know the error is from CPU or NAND when root. If root fail, iTunes will show error code. Then repair according to the code. If the current shows within 50 to 80 mAh, that means CPU is working. The error is from NAND. We can try to replace the NAND. Take out the NAND and check if the phone can connect to PC. If it cannot connect it, then check USB control lines. Check it OK or not. We can replace the new NAND to confirm that if the NAND is bad. After take out the NAND, check the phone and PC connection. If yes, replace new NAND. If not, check USB control lines. If USB control lines is OK, that is CPU error. About the error code, you can take this picture, iTunes root error for reference. Number 4, if the current change as 0 to 50, 50 to 80, 80 to 50 to 0 mA, it means the error is from RAM or I2C. About this, first of all, take out the PCB and take off the cover. Check if any component is broken by water damage or fallen. If yes, then fix it. And then check 1.8 voltage of CPU I2C OK or not. If not, that means some component of this line is broken. Just replace it. And if I2C is OK, that means error is from RAM. Just replace it. If the current changes from 0 to 50 mAh or 0 to 80 mAh when turn on the phone, that might be the error from the I2C lines or up-layer CPU. This is A11 Bionic CPU of Apple. There are 2 layers. Up layer is RAM. If I2C lines are OK after checked, that might be RAM broken. Just replace it. But replace RAM is very difficult. Okay, number 5. If the current is over 100 mA while power on, it means some lines in 28 lines of low voltage power of PMU is short. Just check resistance of all lines of PMU. If any one line is short, use Vosin to find it and fix it. This is iPhone 8 power output detection data. When you need to check the voltage or check the resistance, you can take this for reference. Okay, now I will show you some repair cases for reference.